So in our previous lesson, I told you to draw this graph lah, okay, of x against f, and you should have gotten the directly proportional lah. Okay, but for today, for our lesson, I want to focus on this particular graph, which is the force against extension graph. Now, there is a reason why we have to purposely put it as force against extension. Although, in our previous experiment, our force is actually the manipulated variable and the extension is the responding variable. But for today's purpose, okay, for the purpose of understanding the concept for today, we have to look at it dari sudut pandangan force against extension. Okay, so what I want you to do now in all your three graphs, okay, in all the three graphs, I want you to calculate the gradient, okay, which is the m, okay, calculate the gradient of every graph, and then calculate the area under the graph. So if your graph is like this now, it's a proper triangle, you complete the triangle, okay, then you calculate the entire area, okay, of the graph. So for all the three graphs, I want you to do that. I'm going to give you 10 minutes to do that. And then after 10 minutes, I'm going to call 6 people to give me your answers. Calculate the gradient of every graph and then calculate the area. The area is very simple. It's just a triangle. The gradient, I hope you remember how to count the gradient. Okay, because it's something that you should already know by now. Okay, Ken? Okay, I give you 10 minutes. Do it now. Spring 1. Sorry, stiffness 1, stiffness 3, and stiffness 5. Bahkan, yeah, sorry. Stiffness 1, stiffness 3, and stiffness 5. Okay, stiffness 1, please.
0.25.
Okay, 0.25. What about the third one? Sorry.
0.75.
Okay, 7.5. And the stiffness number 5?
1.28.
1.28. Is anybody's answer different? Okay kah semua? Ada yang bercanggahan? Anybody? Kalau okay, tolong bagi tahu okay lah. Janganlah diam saja. So at least tell me that it's okay. Anybody, your reading different kah from Crispia punya reading? The gradient. Gradient first, 1.23, the last one. Yeah, actually it also depends on how you draw the graph. Okay. Any other difference? The rest all okay?
I think mine jauh, sir.
Jauh macam mana?
My angka kan terlalu besar. Tadi saya rasa saya punya salah sudah. Okay, bye.
Mungkin kamu salah. Mungkin kamu X melawan, no, mungkin kamu X melawan F kali. Jauh kah? No, Mordecai pun bilang jauh.
F lawan X juga, sir.
Oh, okay. Tapi kau punya gradient macam mana?
Yang
Okay,
stiffness
gradient.
1.
Stiffness 1.
Saya punya 3.98.
3.98. Okay. Stiffness kedua, stiffness ketiga.
Stiffness ketiga 7.18.
7.18. Okay. Stiffness kelima.
12.26.
Astaga, 12.26. Besarnya beza. Okay, so you're either on team Crispia or team Melanie ni. So what about the rest? Have you all forgotten how to count gradient? Huh?
Saya rasa value of extension saya yang salah. Saya rasa lah.
Value of extension kamu yang salah. What about the rest? Can the rest give me an opinion, please, based on your calculation? Then just sit down there and be quiet. Otherwise, you end up getting all the wrong things, kan? Then you have to do the experiment again. So better not be silent. Okay, Tian says same as Crispia. Wilson also says same as Crispia. What about the rest? The rest never do. The rest never do means when you come into April, I must slap your face one. Come on, people. What is also Lester? Also apa? Also almost the same as Chris. Lester also the same as Chris. Okay. Mordecai yang jauh. Jauh macam mana, Amor? Sejauh macam si Melanie kah?
Puluh-puluh, sir.
Puluh-puluh. Kamu orang ni ya. Ayo. Okay. Actually, I kind of think that Chris Fia's answer is correct lah. About correct lah. It looks logical to me. The problem is I cannot see your graph, so I don't really know lah. Okay. But I need you to check again and make sure that you get your value of your gradient correctly. Okay. Tapi walau apapun kan, saya mau kamu nampak satu pattern lah. Whether it is the red color or the green color, if you see the pattern makin besar dia punya stiffness kan, dia punya nilai gradient kan akan makin bertambah. That's the point that I want to show you lah actually. Okay, the stiffness makin besar kan, the gradient pula makin bertambah. Okay, that's the first thing that I want you to see. Okay, the next one I want to talk about is the area. Lester, can you give me your area values, please?
For the first one, it's 3061.5.
3061.5. Okay, the second one, the third one. I mean, stiffness 3, sorry.
1014.
1014.
Yeah.
Okay, and then the fifth stiffness?
604.5.
Okay, 604.5. Okay, thanks Lester. How about the rest? Are these values about the same? Dia, kalau kamu kira dengan betul kan, dia tidak akan terlalu jauh lah. It may be a little bit different, like maybe puluh-puluh different, but it won't be like thousand difference lah. What about the rest of you? What do you think?
So,
Ah,
yang stiffness satu tu kan, saya punya 2,000 something.
2,000 something. Okay. Stiffness 3, okay.
Stiffness 3, 794 point something.
Yeah. Okay, actually a lot depends on how you draw your graph lah. But okay, fine. Stiffness 5?
435 point.
Okay, 435 point yada. Okay, what about the rest? Pun sangat jauh kah?
Sir. Stiffness 3140.
3140. Okay. Hold on, I'm changing color. Okay, 3140. Yeah, okay. Stiffness 3?
1040.
1040. Okay. Okay. The fifth one? Stiffness 5?
620.
620. Okay, so quite similar to Lester's one lah. Okay, Christia punya yang sangat jauh.
Sir.
Kenapa saya?
Dah tahu apa yang salah.
Okay, so kau punya
dapat 3,000 something.
Okay, 3,000 lah. I don't think it will run very far from this lah. You should get around 3,000, around 1,000 and around 600. That makes more sense. Okay, but this is the second thing I want you to notice. I want you to notice that when the stiffness increases, the area under the graph decreases. Okay, so this brings two very important things that I want to point out today lah, which unfortunately I cannot write it over here. Okay, the first thing that I want you to point out is when the stiffness increases, stiffness is kekerasan spring lah. When the stiffness increases, the gradient also increases. Makin dia stiff, makin dia besar dia punya gradient. The first thing. The second thing is when the stiffness increases, the area under the graph decreases. Okay, and this tells us two very important information about the gradient and the area under the graph. Okay, now the last thing that I want to ask before I move on is what is the unit of the gradient? Anybody? What is the unit of the gradient? Hey, whenever you count gradient, must have unit one, I know. Anybody want to take a guess? Didn't I teach you all this last year? Yeah, I think I taught you all this last year. Come on. What is the unit for the gradient? Anybody?
Newton per meter.
Newton per meter. Okay, Newton per meter, not Newton per centimeter. It's Newton per meter because gradient is y-axis divided by x-axis. Newton per meter. What about the area under the graph? What is the unit for the area under the graph? Anybody? The area under the graph is actually 1/2 times the height, bahkan. The height actually is the force, kan? Times with the depth, the base. The base is actually the extension. So, if this is the formula, what is the unit for this? According to kita punya unit di sini.
Newton meter.
Okay, it is basically just Newton times meter lah bahkan. Tengok saja ini. Half times height. Height is the F lah kan. And then the base is X. Okay. And this one actually, okay, this brings us a very important formula. Okay. If you notice the gradient, okay, the gradient is actually the y-axis, which is the F, okay, over the x-axis, which is the X lah. Okay. Manakala the area actually is half times the force times the extension from this graph. Okay, so these two important things are half fx and fx actually bring us to the thing that we want to learn today lah. Okay, so I want to talk about so yeah, see the gradient is Newton per meter because you are using Newton, then you're dividing it by meter. Okay, manakala the area under the graph it will be Newton times meter, but we also have a half over there because we are calculating the area under the graph, which is a triangle. Okay, take note of this. So, and in actual fact, Newton meter is actually the unit for joule. Dia punya kawan lah. Okay, it's the same thing except it's different. It's written in a slightly different way. Okay, so whenever we think of joule, people, what do we think of? Joule is the unit for what? Actually, you guys remember? Joule is actually the unit for what?
Energy.
Energy, very good. Okay, so what kind of energy are we talking about when we're talking about a spring? Okay, it's what we're talking about today. So let me remind you once again. Sorry, the area under the graph, okay, which is the luas segitiga here, bila kita kirakan, dia adalah Newton times meter. But Newton times meter actually is joule, which means that the area under the graph is actually the calculation for the energy. Okay, and what kind of energy is it? We are going to talk about in a little while. Okay, so the gradient of the graph actually represents this thing called the spring constant. Remember just now the gradient of the graph is the f-axis divided by the extension. And the force divided by the extension is also known as the spring constant. Dalam bahasa Melayu, spring constant is pemalas spring. Okay, which actually, actually the spring constant is also known as the stiffness of the spring. Astaga. Okay, the stiffness of the spring. Okay, some books will call the spring constant the stiffness of the spring lah. Okay. Sorry, I'm writing this like in a super slow mode lah, cause I'm only using my mouse pad. Manakala the area under the graph, okay, actually is the elastic potential energy. Okay, saya sudah cakap dia energy tadi bahkan. So apa nama energy itu? It is called the elastic potential energy. Okay, so let's go back to the graph again. Remember I asked you just now, right? If we change the stiffness, what happens to the spring constant? The bigger the stiffness, the gradient becomes bigger. Therefore, the spring constant also becomes bigger. Point number one. Okay, very important point. The bigger the gradient, the bigger the stiffness, the bigger the spring constant. Kan stiffness 1 begitu dia punya gradient. Stiffness 3 begitu dia punya gradient. Stiffness 5 begitu dia punya gradient. The bigger the stiffness, the bigger the spring constant. Secondly, what is the relationship between the stiffness and the elastic potential energy? Anybody? Today is anybody day because I really can't be bothered to call names. Anybody? What's the relationship between the stiffness and the elastic potential energy?
The bigger the stiffness, the smaller the energy.
Okay, the smaller the elastic potential energy. Cakaplah penuh-penuh, astaga. Okay, the bigger the stiffness, the smaller the elastic potential energy. Okay, makin keras itu spring kan, dia makin susah untuk mengandungi dia punya elastic potential energy. Okay, so this brings us to Hooke's law. Okay, so Hooke is the scientist behind this extension, this whole elasticity thing lah. So Hooke's law states that the extension of a spring is directly proportional to the force applied. Okay, tetapi ada syarat di sini. Syaratnya adalah the elastic limit of the spring is not exceeded. So everything actually, okay, everything dia ada this thing which we call the elastic limit. Remember our first class, I said and I mentioned to you, I said if you extend the spring, right, after a while, it will become not elastic anymore. Kan? What is the situation where the spring doesn't become elastic anymore? Apa yang akan menyebabkan satu spring itu kan menjadi tidak elastik lagi? Anybody?
Extend.
Okay, you overextend. Not really you overextend but can you put it in a better way, Wilson? Bukan overextend actually. What is it? Sorry, say.
Tarik terlampau kuat.
Okay, fine. Tarik terlampau kuat lah. I will accept that lah. Okay, you put a force that is too big for it. Okay, so this is what happens lah. When you put a force that is too big for the spring to handle you will exceed the elastic limit. Okay, dia ada had kekenyalan tau. So everything there is an elastic limit. If you over tarik or if you put a force that is too big on a spring, okay, what is going to happen is the spring is not going to be able to go back to its original shape. So dia akan hilang dia punya kekenyalan. They will lose the elasticity. So Hooke's law cakap extension is directly proportional to the force. Okay, which means that X and F which means that, wow, what a horrendous looking X, but that's my X lah. Okay, kalau directly proportional, okay, is makin besar kita punya F, makin besar kita punya X. Selagi kamu tidak melebihi the elastic limit. Because what happens is, what shape is this graph supposed to be? It's supposed to be a straight line graph, kan? It's supposed to be a straight line graph, but the moment you reach a certain force, okay, the moment you reach a certain force, where suddenly when you draw kan, dia punya graph akan jadi macam ni. Okay, then you know that this particular part over here, okay, the spring has already lost its elasticity. Dia sudah melebihi dia punya had kenyal. So this particular force, okay, this particular force over here, we call this the elastic limit. It means the spring cannot take a force that is more than this particular F. Otherwise, the graph won't become lurus sudah. Okay, so this is a very important thing. Selagi graph itu adalah lurus, selagi itulah Hooke's law dipakai. Okay, Hooke's law extension is directly proportional unless you exceed the elastic limit. Then dia tidak akan jadi directly proportional juga. Dia akan jadi some weird proportion lah. Okay, so like this lah. Okay, so the equation for Hooke's law actually comes from our gradient. This one, remember the gradient just now I said? Gradient is actually the force over the extension. Kan? This is what we calculated from the gradient just now. Now, I also said that the gradient actually represents the spring constant, and I'm going to use the letter K as the spring constant. Okay, so this is how we will write this. Okay, F equals to Kx, which is our first formula for today. Okay, and because of that, now I can say, sorry, wait, hold on. So because of that, now I can say that if I want to calculate the spring constant, kalau katakanlah saya tiada gradient lah, saya tiada graph. If I don't have a graph, but I can calculate the spring constant by calculating the force and I divide it with the extension. Okay, but the syarat is this extension, okay, apa unit untuk extension yang kita pakai untuk case ini? Anybody? What is the unit for extension? We must use the extension in this unit. What unit is it?
Meter.
Okay, it is in meters. It must be in meters. So be very careful with this because everybody is going to give you the answer in centimeters. Okay, but you need to change the extension to meters because Hooke's law only applies if the extension is in meters. Okay, very important point. Now, don't forget this. Okay, let's talk about the area under the graph lah. Okay, so the elastic potential energy is an energy that is possessed by an elastic material. Okay, tenaga yang terkandung dalam satu bahan yang kenyal. Okay, and spring constant is the force required to extend 1 unit of extension of spring. I will come to this in a little while. The elastic force is a maximum force that can be applied so that the spring will return to its original length if the force is removed. This is the maximum force that the spring will become elastic. Melebihi, kalau force itu melebihi di sini kan, contohnya di sini lah, if I put this amount of force, okay, if I put this amount of force, then the extension akan menjadi sangat teruk sudah lah. Because dia sudah hilang dia punya elastic. Remember, Hooke's law only applies selagi spring itu masih elastic. As long as the spring is still elastic, then Hooke's law boleh pakai. The moment dia spring hilang dia punya elasticity, then Hooke's law tak boleh pakai sudah. Okay, so Hooke's law dia cakap directly proportional, bukan weird looking shape graph lah. Okay, so as I said just now, the area under the graph, as in the triangle, is actually half of Fx. And since the area under the graph is the elastic potential energy, this is the second formula that I want you to remember lah. Okay, elastic potential energy equals to half of Fx. Now, if you're thinking in terms of the question, kalau dari segi soalan lah, okay, you have to look at it in two ways lah. Number one, if they give you the graph, if they give you a graph and they ask you to calculate the spring constant and the elastic potential energy, then you have to use the gradient and also the area under the graph. But if they give you no graph, they give you a situation, then you have to use the formula. The formula is half Fx for elastic potential energy and the spring constant, which is K equals to F over X. Okay, that is, so it depends on the soalan yang perlu. Nanti kita akan jawab lah. Okay, besides this, since F equals to Kx, kalau saya masuk F equals to Kx in this formula, okay, what I will get is, I will get another formula for potential energy yang hanya melibatkan the spring constant and also the extension, which is half Kx squared. Okay, so take note now, people, there are 3 formulas now. Number 1 is the formula for the force, F equals to Kx. Number 2 and number 3 is the formula for elastic potential energy. But one hanya melibatkan F dan X, and the other one hanya melibatkan K dan X. Okay, so yeah, so please remember this now. Okay, let's talk about the stiffness of the spring just now. Remember the relationship you gave me just now? You said that the bigger the stiffness, the bigger the spring constant. Kan? The bigger the stiffness, stiffness 1, stiffness 3, stiffness 5, right? So the bigger the stiffness, the bigger the spring constant. So what does a bigger spring constant mean lah? Okay, so for example, let's say this spring constant is 100. And then the second spring constant, okay, which is this one, look at the gradient, the gradient is smaller bahkan. Spring 1, the gradient is bigger. And we already said lah, if the gradient is bigger, then the spring constant is bigger. So what does this mean? This means, so this 100 means that you need 100 newtons of force to extend the spring by 1 meter. Okay, 100 newtons of force you need to extend the spring by 1 meter. Manakala, spring number 2, you only need 50 newtons of force if you want to extend the spring by 1 meter. So think about these two situations and tell me which spring is more keras. Which spring is stiffer? The actual word for kekerasan bukan hard tau. Is stiff. Okay? Stiff as in, keras another way lah. Tetapi dia bukan hard bukan hardness of the spring. Okay? Tapi stiff. So antara spring 1 and spring 2, which is the more stiff spring? Anybody?
Number 1.
Spring number 1 is stiffer because you need more force to extend by 1 meter. Manakala spring number 2 is less force. You want to extend 1 meter, you need less force. So it's not so keras lah. It's less keras, less stiff. Okay? So this is a very important point. The gradient actually tells you two things now. Number 1, the value of the K, which is the spring constant. Number 2, it also tells you how stiff, which one is the stiffer spring. Okay, so the bigger the gradient, the more lurus the gradient this way, okay, the harder the spring is. Okay, it's a very hard spring. So this is a stiffer spring, and spring number 2 is a softer spring. Okay. All right. So look at this question. Okay, this is a question that has a graph. Okay, I want you to calculate the elastic potential energy when x equals to 10 centimeters. Okay, so I'm going to do 10 over here. Okay, so for spring A is 30 newtons and spring B is 10 newtons. Okay, all right, I want you to calculate the elastic potential energy first. And let's do this first, the first one. Calculate the elastic potential energy first. Everybody, please calculate now.
100 joule and 50 joule.
150, yeah? Okay. So
No, 100
Yeah,
and
I know.
another is 50. Okay.
Okay, so B is 50 joules. Okay. So let's take a look at this. Diorang ni kan, lain lah soalan, lain lah ano. Okay, doesn't matter. Okay, so this actually what they did was to calculate the stiffness of the spring lah. I mean, calculate the spring constant. Tapi ini senang lah. All you have to do is just calculate the gradient. Remember, if they give you a graph, the spring constant is calculated by using the gradient. Okay, manakala the elastic potential energy is used by calculating this one. Okay, so Idina, why do you get 100 and not 1? Do you know where you went wrong?
The X is cm.
Correct. The X is cm. The X is actually supposed to be in meters. Okay. Everybody, please take note. I have mentioned this already. Make sure that your extension is in meters. Okay. Otherwise, you're going to get a lot of tongue wagging. So actually, the elastic potential energy for spring A is 1 joule. Manakala, the elastic potential energy for B is 0.5 joules. So if you had changed the extension to meters, then you would have gotten the correct answer lah. Okay, so please take note of this, people. It's very important. A lot of people make this mistake. They forget to change it to meters. Now, soalan is, if each spring is extended by a force of 10 newtons, now you have a force of 10 newtons, what is the extension of the spring? So use the force equals to K times X. Astaga, sorry. Force equals to Kx. Okay, to find the value of the X. Now our force is 10. We've already calculated the K, okay, by this one lah. So for spring A is 200 Newton per meter. For spring B is 100 Newton per meter. Can you calculate the extension, please?
0.05 meter and 0.1 meter.
Okay, so it should be 0.05 meters and the other one should be 0.1 meters. Actually, incidentally lah, okay, you can actually also calculate it from the graph. Look at spring A. Spring A. So there are many ways to do this lah. You can either do it calculatingly, or you can actually use the graph. The force is 10 newtons. So 10 newtons, then you see that, oh, okay, it's actually 5 centimeters for spring A. Manakala for spring B, okay, is 10 newtons. Sorry, 10 centimeters or 0.1 meters lah. Okay, so take a look at this, people. The same force, but the extension is different. Spring A, the extension 5 cm saja. Manakala spring B, the extension is 10 cm. Why? Because spring A is stiffer, dia lebih keras. You need more force in order to give you the same extension. Okay, so all these semuanya adalah berkaitan tau. Okay, please think about this lah. So that's why lah. This is a stiffer spring and this is a softer spring. Okay, kita buktikan secara pengiraan dan kita juga buktikan secara graph. Okay, so spring B is suitable to extend with small energy. Yeah, okay, it's easier to extend spring B sebab dia tidak begitu keras. Okay, this is basically what I want to cover today lah. Now there's a lot of things that there is actually a lot of things that is being covered today. Okay, and of course it doesn't help that I'm in a situation where there are people shouting all around me lah. Okay, saya rasa macam saya berada di pasar ikan ini. Tapi, well, there you go lah. So what I want you to do today, okay, what I want you to do today is to take a look at this. Okay, the file. So in the file, okay, for your work today, astaga. Okay, in the file for your work today, I want you to please answer every question in page 16. Okay, answer every question in page 16, but I also want you to look at page 15. Okay, take a look at this. So all the formulas are actually here lah. Okay, but you notice that the formula actually, not just the formula, but the graph itself is not complete. Okay, so I want you to, and this one also this is mesti kamu scan dan hantar di Google Classroom lah. Okay, what I want you to do is, I want you to complete these notes over here. Okay, tell me kalau kamu diberi graph ini bahkan, what can you calculate from the graph? What are the two things you can calculate from the graph? You can calculate the gradient and the area under the graph. But what does the gradient represent? What does the area under the graph represent? Okay, and then talk to me, and then write down over here so that you don't forget when you have these notes. Okay, write down over here. How do you know which is a stiffer spring? How do you know which one is easier to pull? Which one is this? Okay, so I will try to put up this video as fast as I can. Yeah, as fast as I can, so that those of you who want to review and you want to rewrite your notes over here, also can lah. But I want you to scan this full page. Okay, scan the full page and upload it into the Google Classroom by tomorrow lah. Okay, by tomorrow before our class. Okay, so two things you need to do. You need to do all the 3 questions exercises over here, and I also want you to do a little bit of short notes. Okay, so that you process what you have just learned. Yeah, okay, process what you have just learned, put everything down in here, and I believe that it will help you lah.